So, occlusion culling. Culling is basically where where Unity is trying to prevent what's called overdraw, because when your scene is drawn, multiple objects are being drawn at the same time, and sometimes they're also being drawn in the same place on the screen. And what happens is if one object's drawn and then another object is drawn entirely in front of it, I guess it's better from this perspective, then you don't want to see the one in the back. You only want to see the one in the front. You don't want to draw the one in the back because that's wasted resources. So a culling is where you're going to try, or occlusion culling is where you're going to try and detect when you can not draw or cull the object in the back. So real quickly, we can actually see where overdraw is happening. If you in the scene view in the top left, you can switch your shaded view to overdraw. It's there somewhere. Yep, and that will actually show you how much overdraw there is. So you can see, for instance, all of those tires have a lot of overdraw in the middle, and you can't really optimize overdraw for vertices within a single mesh, but you can optimize it per object. If you have two objects, one in front of it, one in front of the other, you can use the object in front to hide the object in the back. You see where some parts are lighter than others?
So everything's sort of semi-transparent, so if it's more solid, it's being overdrawn.
Yeah, that means there's more stuff being drawn there than is potentially necessary. A good example is if you look at one of the tires from behind the sign, like try and place one of the tires entirely behind the sign, or one of those signs. Yeah, all those tires don't need to be drawn, but they're going to be drawn. They're going to be put in a draw call because they're all behind the sign, but Unity doesn't know that it shouldn't draw them. So occlusion culling is going to say, hey, there's an object here. We don't need to draw those. So with occlusion culling does come a couple things. You will get some CPU overhead because it has to determine what objects to hide, what objects to not hide. There will be a bit of a memory footprint, which we can take a look at when we actually get to baking occlusion. But generally speaking, in larger scenes, especially where not much needs to be visible at once, it can be a very good uplift in performance. Let's first look at how to kind of enable objects to be occluders or occludees. So in occlusion culling, you have two things. You have an occluder, which is going to be hiding an object, and you have an occludee, which is going to be an object to be hidden. Now, an object can be both. You can have an object that is both occluding other objects and being occluded. So it will be culled or cull other objects. The most important thing is when you allow an object to be an occluder or an occludee, it must be static. How about let's look at occluders first. So the easiest way to set this is if you click on an object like that sign, for instance, and check the drop down next to static. You can set it to an occluder or an occludee. So if you set that to an occluder, there's a couple requirements for it. It has to be static, first off, because what happens when you do occlusion culling is you're actually baking the occlusion data into an asset that is loaded during runtime. So
would this be considered static now that I've clicked this one thing?
Yes, it would be, but not for everything. But I mean, a good rule of thumb when you make something static is you're making a promise to Unity that you won't move it. So if you make something static, you should not move it because Unity is going to assume that you're not going to move it. And if you do, it can have weird effects. Like if you would do occlusion culling and bake your occlusion and then move an object that was baked, you're going to see things hidden behind it or behind where it was, even if it's not there. And that goes the same for anything that's static. Let's see. So another thing is it must be opaque. If it has a transparent shader, it will not occlude things.
Right.
And it can only be a terrain object or a mesh renderer. It can't be like a skinned mesh renderer, like if you have like an animated character or something like that. One other thing, with level of detail, it will use the first level, so it will use LOD 0. So if you have significant differences in like the like the silhouette of an object, between LOD modes or LOD levels, then it will only use the first one, the highest detail one.
Would you say?
Occludes. Oh yeah.
Would you say if you just press the static, so say for example, all these objects, all these tires, for example, if I just sure that'll do. So if I just put that on, so all of it's on,
Mm-hmm.
basically that's the occlusion culling sorted, right?
Essentially, yeah.
Right.
Well, it's
With the other factors.
allowing it to be and working with occlusion culling. But if you just built it right now, it will not do any occlusion culling whatsoever. There will be none.
Okay.
So that's where baking comes into play. So first, with objects that are being occluded, so occludees, that works on smaller objects that will usually be behind things. Transparent objects, that's also a good. It'll work fine on transparent objects if you're trying to occlude them, because it's just like any other object. An occludee does have to be marked as occlusion static to be baked into the occlusion data, but dynamic objects can be occluded. There is an option on mesh renderers called dynamic occlusion that will allow them to be occluded by static occludees. It's somewhere in there. Yeah, at the bottom. So static objects can be occluders. Dynamic objects can be occludees. Static objects can, of course, also be occludees. But a dynamic object cannot occlude static or dynamic objects. Okay, if you mark something as occlusion or occludee static, by the way, it also cannot move, or else it'll mess up the occlusion data that's baked.
When does it bake it?
So let's get into that. The occlusion culling window is if you go to window rendering, it's just called occlusion culling.
Cool.
Yep. So this is where you actually enable occlusion culling.
Oh.
So if you go to the bake tab, there's some settings there. Smallest occluder is the size in meters of the smallest object that will be occluding other objects. If an object is smaller than that, it will not be occluding another object. You usually want to set that as high as you can to get the kind of occlusion that you want.
Are the defaults usually okay or not so much?
They're okay.
Okay.
You'll want to fine tune them, but generally speaking, they should be okay. Smallest hole is the smallest hole through which a camera can see in meters. So, like, if you have a hole in a wall that's really far away, then if it's smaller than that size in meters, it will cull whatever's behind it.
Mm.
But if you have like objects like that with small holes really up close, you may not want to have that be a very large number. So again, for both of those, you want them to be as large as possible while still getting acceptable looks, because that'll reduce the size of the baked data. Backface threshold, that's a bit of a weird, more advanced setting. I've never touched it personally. I don't think there's much reason to, unless you really think you can get some performance out of that.
Mm.
So 100% is usually good. But yeah, you can go ahead and just click bake in the bottom right, and it'll start baking that. So hopefully you might get some stuff. Cool. So it baked that really quickly. But if you have a really large, complex scene with a lot of static objects, it might take longer. Now, what you can do is you can actually visualize this. Do you have a camera in your scene still? I think you do.
Yep.
Yeah. So if you enable gizmos again, I think that's necessary.
That's new.
Yeah, there it is. So you can kind of see these larger like areas. And if you move your camera around, you can see in the scene view what parts are going to be rendered. If you have, like, if for instance, if you moved your camera behind that sign, those tires would most likely not show up. If you, like, you have to move the camera object.
Ah, okay.
So yeah, it's the opposite way. You can already see them being occluded by the frustum. So frustum culling is something else it does. If something's outside the camera frustum, so the amount of space or the stuff you see there, then it's not going to be included, which is good too. For some things it doesn't actually look good, so you have to decide whether that's good or not.
Okay.
But yeah, so if you move it behind the sign,
would width be a thing? So does it have to have a certain depth before it triggers the occlusion? Because these signs are pretty thin. There we go. Let's bump that up to 0.5 because that was way too slow. Okay. Yeah. So depth of objects makes a difference.
One thing you can also notice is the shadows are still there.
Yeah.
The reason they're still visible, like the real-time shadows, is because occlusion culling does not affect what your lights can see. So it only affects what your camera is drawing. So if you're worried about objects that aren't visible not affecting your shadow maps, you don't have to worry about that, because Unity will still draw those objects in the shadow maps. What it also does, though, with shadow maps, which is a nice automatic optimization, is it limits the frustum of the shadow, like of the light camera, to just what is visible in your games camera. So it will not actually render shadows outside of that range. Now that does include the scene camera, so you can still see shadows here because of your scene camera.
That's cool.
But yeah, you can kind of see it disappearing over there.
So what were the conditions again, just to cover that? So it had to be static. If all of them are on, it's static. Mesh renderer, dynamic occlusion is optional, but you can do that.
Mm-hmm. It has to be opaque. Occluders have to be opaque.
Has to be opaque. So let's click on the sign. Any other factors? So opaque, standard. Opaque, standard. Any other factors?
Maybe? No, I don't think so. Now there is one other thing with that is if you have multiple scenes, usually what you do if you have just one scene at once is you would bake your occlusion for that one scene. But if you have multiple scenes being used at the same time, like in Mona we do, what you actually would want to do is if you load, I believe the space scene is loaded first. So you would want to, for instance, unload all your scenes and then load just your space scene and then load the other two scenes after that. Just drag them into the hierarchy. You can bake all three of the scenes at once. And what'll happen is when they're loaded in runtime, it will use the same settings. If it detects that those three scenes loaded in the correct order are using the same settings, it'll just load the data. It'll just load the data once and use it for all three scenes. If you don't do that, if you render or bake it per scene, you'll be loading 3 times as much occlusion data, or 3 separate sets of occlusion data as opposed to just one. So with multiple scenes, it's good to bake all of them at once.
The 3 scenes should be like they are now, and when you press bake, it'll do it all?
Yeah. There is something to be said about scene loading. Pretty sure Mona loads the space scene first, and then the other 2 scenes. If it does it that way, where it loads the space scene first, and then the other 2 scenes after that, as long as you do the same thing, you make the space scene your primary scene by loading it first, and then add in the other 2 scenes, and then bake it. Should bake it for all of them at the same time.
Okay, so as long as all 3 scenes are open, when you press bake, it'll do that one time, and that'll be fine.
Mm-hmm.
Right. Okay.
So the CPU overhead is is like a constant for your occlusion data. It would be a memory footprint. The more tiny areas that you have, the more data you're storing, and the more you have to load into memory. Actually, go back to the occlusion tab if you can, real quick. And at the bottom, it should say how much memory it takes up.
At the bake?
So
there we go.
Yeah.
41K.
Yep.
That's a 0.5.
So this is a very small scene.
Yeah, very small scene.
Yeah.
0.5. So let's do a 0.1 and see how big that gets, I guess.
Yeah, you can get multiple megabytes, so you want to be careful with that. So yeah, with occlusion culling, there's a small CPU overhead, but you're more worried about how much memory it takes up. So yeah, optimizing these settings for your scene is going to be a good step in ensuring that is done appropriately.
253 on that, so yeah.
Yep, so that definitely increased.
Cool.
Okay. There's just two more things with occlusion culling. The first is occlusion areas. So you can just add an occlusion area component to just like an empty game object, and it'll let you define how much space it takes up. And what an occlusion area is essentially it is kind of it is defining where a camera is most likely to be. So, for instance, if you have multiple rooms, it would be great to put one of these in each room. And what happens is it will calculate higher precision occlusion data in each of those areas, and anything outside will use lower precision data, which takes up, of course, less memory, and there is actually less CPU overhead from that. And the areas inside will be calculated at a higher precision. And then when you go outside of an area, when your camera goes outside of that area, the objects inside, or the occlusion data inside that area, will be used or calculated at a lower precision. So using occlusion areas can help improve your occlusion bake times, and it can also help improve your performance while using occlusion culling in your game. It's not necessarily where you're looking, it's where your camera is positioned. Right. So your camera has to be inside of an occlusion area for it to take effect. But yeah, it's the same kind of idea.
Like when I'm in this area, pay more attention to the things in this box.
Yes, exactly.
Right.
So that's why it's where your camera is more likely to be. One thing to mention with it is you need to have that checkbox, is view volume enabled, otherwise it won't work. Because by default, if you don't have any of these, Unity will create one massive view volume for your entire scene and render everything or bake everything at a higher precision and load it all at a higher precision. So this can help optimize. One last thing is Occlusion Portals. Occlusion Portals will let you kind of create an occluder that isn't necessarily tied to a mesh renderer. So if you add a portal to an object, it can block things that are behind it without necessarily needing a mesh. And you can define how much area it takes up. And that's good for things like if you have like an animated doorway, you could animate whether this portal is open or not, and have that, like when you open the door, you can disable the portal and you'll let you see everything, but when you close the door, you could re-enable that portal and it would cull everything behind it. So you could use it to kind of represent the occlusion of objects behind dynamic objects. Not in a super precise way, but in a little bit better than it would be otherwise.
So you would sort of show or hide this with animation on a door, perhaps. So yeah, this can be animated. This can be animated, basically.
Mm-hmm.
Right.
Yeah, it's just an open option on the portal.
Right.